Conclusion. There are two main ideas I want you to get out of this talk. The first is that finding defining equations for matroid varieties is hard. As we saw from those 5 mathematicians, all hell breaks loose when we try to do it. And even when we tried to prove that defining equations we had for the pencil matroid variety were, in fact, the defining equations, it took 2 years to prove it. The other main idea I want you to get out of this talk is that the Grassmann-Cayley algebra lets us find some of the defining equations by using the geometry of the matroids when thought of as point configurations. So this paradigm shift we had, where instead of thinking of matrices, we thought of points in the plane, turned out to be useful. I want to outline some further work that we're planning to do. First of all, it's not clear that the equations we found for V Pascal are the only defining equations for the matroid variety. We checked using the software Macaulay 2, and there's evidence to say that they are the only defining equations, but we haven't been able to prove it yet. So that's the immediate next step we have. But we also want to look at defining equations for matroid varieties given by other point configurations. For example, Pappus's theorem, which is another theorem in classical projective geometry. And then later on, we want to look at defining equations for matroid varieties given by wheel graphs. Wheel graphs are a class of graphs that provide fairly simple but non-trivial matroid varieties for us to study, and the defining equations for them are not obvious. Now for the Q&A. What do you love most about mathematics? I think I like the abstract thinking that comes with mathematics. I've never been someone who enjoys writing essays or writing my opinions. I'm much more comfortable with things that can be proved. I remember when I was a kid, I used to drive my mom crazy by saying, "You said, but you said, but you said we could get ice cream, but you said we could go to the zoo," whatever. And the way it's translated in my career has been, but the theorem said. The theorem said we can do this. The theorem said we can do that. I think making connections in that way is very beautiful to me, and that's what I like about mathematics. What was your favorite math topic as an undergrad? It started out as topology, and this was because I was a physics major. I was interested in string theory, and so I wanted to learn topology to try to understand that better. Then I took an abstract algebra course, and I really enjoyed rings in particular, which is what I study now. I've also always loved classical projective geometry, and you can see some of that in the work that we did for this project. How did you prepare for graduate school? There were a lot of things I did. I did RU's, research experiences for undergrads. I did the MAS program at Penn State. It's a semester-long math program. And there are other programs like it. You may have heard of Budapest Semesters in Mathematics and Math in Moscow. Those are very similar programs. I would definitely recommend you do at least one if you're thinking about going to grad school in math. They offer pretty good preparation for it. I also did math competitions, in particular the Putnam. And I think one thing I regret from undergrad is that I didn't do the Putnam more than once. I wish I had done it all 4 years of undergrad. If you get accepted into grad school, make sure you start studying for the quals the summer beforehand. That's also a good way to prepare for grad school. What was the most challenging part of grad school and how did you handle it? Well, in spite of all the things I just told you, when I got to grad school, I really didn't feel prepared at all. It seemed like I had the raw ingredients. If I got in, then I must have been smart enough to handle it. But I didn't have the advanced coursework. I never took any grad level courses when I wish I had. Um, and I just didn't have the experience with math courses that some of my peers had. Because of that, I felt very, very intimidated by my peers. And then there was also a class difference that I felt really strongly. Um, because I, grew up with not a lot of money, and I didn't go to an Ivy League school for undergrad. And I spent so much of my adult life already working when I was in school with people who had never worked before. Um, this sort of class difference was a little bit of a culture shock for me, and it was very distracting to me in my studies. So some of the things I did to overcome that, um, first of all, I found some friends. It's always important to have a good social network. I also, a lot of times, would just sit down and do the math. If there was a homework that I felt was really challenging or just looked really scary to even start, I would just sit down and start on it and give myself credit for the little bits I could do at a time. The other thing that was helpful was office hours. Um, don't ever feel like your questions aren't good enough for office hours. If you have a good professor, they'll listen to you and answer your questions. And if you have a bad professor, then they'll still answer your questions because that's their job. And as far as you're concerned, that's all you want, is for them to answer your questions. You don't need their judgment. Do I have any general advice for students considering pursuing the doctorate? Yes, I think the biggest piece of advice I can offer is to believe in yourself. Um, find faculty who believe in you. Even if it doesn't feel like it, there are faculty who believe in you. And the faculty who don't believe in you, ignore them. I've had my fair share of experiences with things professors said to me that made me feel less than or made me feel like I didn't belong there. And the way to deal with it is to just to move past it and ignore it, and only listen to the professors who actually believe in you. You should also rely on your friends for that social network, and talk about math with your friends. This could be friends that you make in grad school, but this could also be friends that you make on forums. You could start a blog to talk about math. These aren't things that I've done, but I have a lot of times visited forums when I had a random math question. There's usually someone who can answer it online. And I never started a blog, but when Google Plus was a thing, I did post a couple of math ideas there, and was really happy when some of my friends responded. My posts were mainly about how to do things using LaTeX, but that's a start. So if you want to contact me, you're more than welcome to. My email address is awheeler@mountholyoke.edu. You should also comment on this video since it's on YouTube, and I'll do my best to answer the comments. Once again, thank you for inviting me to speak, and I really enjoyed giving this talk.